You ever wonder why a website can feel lightning fast one day and then just sluggish the next? Well, a lot of the time, the answer is hiding in this kind of global maze of competing cloud platforms. So today, we're going to find the secret path through that maze and figure out what really makes the internet feel fast.
All right, so let's just dive right into the main puzzle here. You've got two of the most powerful computer networks on the entire planet. Think Amazon and Google. So why on earth can sending a tiny piece of data between them sometimes feel like you're stuck in rush hour traffic on a cross-country road trip? Let's find out. So the heart of this puzzle is something called multicloud. And really, you can just think of it as a strategic juggling act. Companies don't want to put all their eggs in one basket, right? So they mix and match services from the giants, AWS, Azure, Google Cloud, to build the absolute best app they can for the best price.
To really get what this means, picture an app like a person. Okay? Its brain, the part that does all the thinking, that's running on Amazon Web Services. Its memory, where all the data is stored, that's over on Microsoft Azure. And its limbs, the part you actually interact with, well, that's on Google Cloud. The real challenge is making this distributed body act like one seamless, super responsive person.
So to make that happen, engineers can't just, guess. They have to measure performance, scientifically. But what are they even measuring? Well, it all boils down to two key numbers that pretty much define the rules of this digital race. And trust me, they're concepts we can all wrap our heads around. First up, there's latency. This is the delay that you can actually feel. You know when you click a link and you have that split-second wait for the page to even start loading? That's latency. In our race analogy, it's the lap time for a single car. It's just pure speed. And just like in a real race, the lower that number, the better. Now, the other side of that coin is throughput. So if latency is how fast one car is, throughput is how big the entire highway is. This isn't about speed, it's all about capacity. How much data or how many cars can you move at the exact same time? And for this one, you want the biggest, widest highway you can possibly get.
Okay, so let's tie this all together. Latency is that first, kind of frustrating delay when you click a button. Throughput is what decides how fast you can download a massive movie file. For a really great experience online, you need both low latency and high throughput, but they are totally different pieces of the performance puzzle.
So how do engineers actually get these numbers? I mean, they're not just throwing darts at a board. They run a very structured scientific investigation with a whole toolkit designed for this.
And it's basically a simple three-step experiment. First, they pick their tools for the job. Second, they define the exact racetrack they're testing, like say from a server in Virginia all the way to one in Frankfurt, Germany. And finally, they just hit go and measure both the speed and the capacity to get the real-world numbers.
Okay, theory is great, but let's put it to the test with a real-world case study. We're going transatlantic for this one, and I've got a feeling the results are not what you might expect.
So here's the scenario. A company needs to connect its app, which is running on AWS on the US East Coast, to a database that's running on Google Cloud over in Western Europe. This is a super common setup for any big global business. So now they have a choice to make. Path A is to use the public internet, the same network you and I use every single day. Or there's path B, using a special private route that leverages the cloud provider's own secret networks.
So what do you think? What's your gut tell you? Is it the wide open public internet, or is it that private direct route? Which one's going to be the faster track? And the results are in. And wow, it is not even close. As you can see, that private path is way faster. We're talking about a performance boost of over 20%. In a world where every single millisecond matters, that is a massive, game-changing difference. And right here, this is the key takeaway from that entire test. It proves that our intuition about how the internet works can be totally wrong. The most direct, most public route, it isn't always the fastest. There's this hidden, more efficient path that's working just out of our sight. So what is this hidden path? Well, the secret is something they call the private backbone. And it's basically a private, global superhighway built just for data, and it's owned and operated by the cloud giants themselves. There are no traffic jams, no detours, just a crystal clear, optimized shot from point A to point B. But look, this is so much bigger than just one speed test. The fact that these hidden highways, these massive private networks even exist has huge implications for the future of the internet itself. And this is exactly why it should matter to you. Because when an app uses these private backbones, you feel it. It means your movies buffer less. Your online games are way smoother.
The whole digital world just feels snappier, more responsive.
But all this leaves us with one last kind of provocative thought to chew on. As these incredibly fast private highways get bigger and better, what does that mean for the public internet that the rest of us share? Are we heading toward a future with a super fast express lane just for big tech, while the public lanes kind of get left in the dust? It's a question that's really going to shape the future of how we all connect.